Okay, folks. So now what we're going to do is we're going to go here to section 3.4. So it is now at this point, if, so sorry, actually 3.4, this is applications of set theory. So it is at this point where if you have been like using AI to really help you with your homework, it's gonna break here. It's not going to do that well. Um, it's when you add in too many steps into an AI, it usually breaks it when it comes to math. So the math we're about to do is not going to be very hard. The section itself is not very hard math wise. It's very hard logic wise, right? You have to set it up properly and understand the question. But at its core, we're just doing like 100 minus 80 and stuff. But it is at this point where if you are using AIs. It's going to cause problems for you. And this is where I want to reintroduce you to your lovely textbook solutions. This document, it is a 300-page document of fully debriefing the solutions here for everything. This is available on the introduction page. You have this. This is meant to be a resource. You are meant to consult it. Remember, these textbook exercises, yes, they are assignments. And yes, from this point onwards, the amount we're going to require for each one is going to decrease. Now I'm only going to ask you for 1 to 2 questions. It is meant to yes, it is for marks. It's not worth a lot of marks. The goal of these assignments is twofold. One, it's to encourage you to practice these skills, and two, it lets me, your instructor, get a good base as to where you are, as whether or not you're missing like a concept or something, or you're doing something wrong, or you got it right, but eventually this is going to cause a problem. So that's how I can check in with you. It's me seeing your work and being able to figure out that okay, you're good to go, or versus like, ooh, I probably should intervene in this point. So if you're using AIs, it's going to cause the problems here for you. So that said, we're now going to use applications of this. So this is where this is actually used in the real world now. And you don't see it used a lot, but it is used a lot. So we're going to start out here with this one here. Mhm. So Rachel surveyed a group of 12 students and how they communicated with friends over a weekend. So in this case, we're not actually given numbers, we're given percentages. Kind of tricky to be able to figure that one out in this case. So we can still use these, right? If I know that, a bunch of circles here, if I know this adds up to 100%, well, if I put a 5 here, that just means it's 5%, right? So what we're going to do is we're going to use this Venn diagram here. So quickly pause the video, get this in. So 3, 2, 1. Okay, so at this point you should be on pause. So what percentage of teens, so what's this question asking us? What percentage of students used at least one of these 3 forms of communication? So there's our question, right? So used at least one. So let's think about this here. So the first thing to kind of know here is I need to label some stuff, and you can see that this has already done this. So for example, cell phones are red, it's our C. Texted is our T, and social media is our S here, right? So this is saying that, hey, in this entire circle here, it's 66%. That said, 66 is not going to be this number here. It's 66 is not here, right? Because remember, 66 is the whole circle, and I got this thing, I got this thing, and I got this thing. So I have the teens who use a cell phone and text. I have teens who use a cell phone and use social media, and I have teens who use all three. So all of those encompass in that 66, right? That's what we learned earlier. So let's start out with stuff that we do know. And you always want to start out with this section here first. So here's what I know. I know, nope, that there are 12 people who used all three forms of communication. So that's the first thing we know. Now, what I also know is that 19% texted and used the social media site, right? So texted and used a social media site. So that's this part. Now you have to remember though, this 19, this is people who use texted and social media, but also some of these guys also, at least 12 of these guys use all three, right? So it's not actually 19 that goes in there. And I'm not going to write this every time, but just for this example, it's 19 minus the 12 people who all use it. Actually, it's 7 in this case, right? So check. So again, why did I get the 7s? Because this whole part here is technically 19, right? Yes, 19's here, but I know that 12 of these guys use all three. All right. So now we have 18% who called on a cell phone and use a social media site, right? So cell phone, social media, they're looking at this part here. And just as before, well, if there's 18% here, 18% here, well, 12 of that percent goes there, right? So actually, 18 minus 12, it's 6 in this case. And then same thing before, right? Cell phone and texted. So at this point, pause the video. You should be able to get the answer. I'm going to go over in 3, 2, 1. 56% called on a cell phone and texted, right? So 56 minus 12 gives me 44 here. Okay. So at this point, we've done the hard part. We have our interceptions here. We have our commonalities established. Now we can just do the people who only do one thing at a time. Which brings us back to our main point. Whoop. So again, this whole highlighted part here is, this is the cell phones, is 66. But remember, it's 66, but then I got to take away the 44 people. I got to take away the 12 people. I got to take away the 6 people, right? So 66 minus 44, that's 22. Minus 12 is 10. Minus 6 is 4. So there are 4 people who only called on their cell phone, right? So at this point, pause the video, do this one, right? Only social media, only text. So 3, 2, 1. Right? So for only text, again, it's 76, but I got to take away these 44. I got to take away these 12. I got to take away the 7. You do that, I get 13. Now, again, I'm just doing this math in here to kind of show you guys it is fine if you guys just do just the numbers. Okay. If you put that is fine, but you ideally want to be showing that work there, right? Because that helps me know something's wrong. So you don't have to do it in here, but you should be doing that at least, out here, for example. And then finally, you're going to have 9 here. All right. So again, what percentage of students use at least one form of these 3 communications? So what is the question here actually asking? What would the answer be? So what is this actually asking here? Well, it's asking for you to find the people who, well, one, to find how many people use all of these, right? That's where we're going. Use all of these. Right? Sorry, use one of any of those, right? So I'm going to use basic numbers for now, but later on in this video, we'll actually use set notation. But in this case, let's think about this, right? So I know I have 4 people who use only text. I have 6 only cell phones. I have 6 who use cell phones and social media. I have 44 who use cell phones and texting and so on. So I'm just adding up these numbers, right? So 4, 6, 44 plus 12 plus 9 plus 7 plus 13, right? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Yep. So I've done that all up. So if I add all those up, I'm going to get 95% of people use at least one social media. So I'm going to change this question then. What percentage of students do not use any of these. They don't use social media or talk on a cell phone or text. I don't know, maybe they send letters or something. Well, again, we have 100%, right? We got to take away the 95% we know use them. We'd get 5% in this case, right? So 5 should be outside of these circles, but still within the overall universal set. Okay. So again, nothing about that math itself is hard, right? But you can see how you have to set it up correctly. You have to understand what it's asking you here. So I want to do this one here actually, because this one I gave you a Venn diagram. What happens if I don't give you a Venn diagram? How can you figure that out then? So let's try this one here. Doo-doo-doo-doo. All right, so Sarah conducted a survey of teen gaming preferences. Here's her results. 20 people play online games. O. 20 people play game consoles. G. 20 people play on their cell phones. C. She surveyed only 31 twins. So how can this be? Well, realistically speaking, how can this be? Some teens play multiple options, right? So you might have some teams who play online games and game consoles. You might have some who play on their cell phone and online games. You might have some who play all three, for example, right? So it's not going to be like a 60, it's not going to be a it's not 20, 20, 20, right? Just like up here, 66 was not actually the answer here. All right, so um yeah, let's try example 1 here. Now, really look at the title here. Principle of exclusion and inclusion. Oh, what did I just? There we go. Principle of exclusion and inclusion. What's that again? What's that again? What's that again? Crap, what do we do? Here we go, right? Again, this is where I'm trying to find, if I have two things here. Oh, come on. I have two things here, right? This one's A, this one's B. To find out what A union B is, to find out what both of these things are, I need to take A, which is all of this, B, all of this. This got counted twice. So I need to subtract that from it to make sure it's only counted once, right? Because right now what's happening is, well, okay, I'm counting all of A and all of B. This is counted twice. So I got to remove that it's counted twice. That's what that is. All right, so let's go do this one here. So example 1. Sure. You guys don't have to do the drawing. So what we have in this case is we have to use the following clues to answer the questions below, which are these ones here. So we have 28 children who have a dog, a cat, or a bird, which is going to be our universal set. Now we have 13 children who have a dog, which we're going to say is A. We have 13 who have a cat, which we're going to say is B. And we have 13 who have a bird, which we're going to say is C. So already we can see that, that adds up to 39, right? That's not working out. So what we're going to do is we're going to draw ourselves some Venn diagrams here. So let's start off with this. So we have 3 separate things, because then it goes into like dog and cat, dog and bird. So we have 3 main categories here. So let's go this 1, 2, 3. I'm just going to move this stuff a little bit. Go. Yeah, that looks right. Now, and then again, all included in a box. Oh, I see. All right, there we go. So we're going to say that this one here is A, which we said was dog. We're going to say this one here is B, which we're going to say is cat. We're going to say this one here is C, which we said was bird. You know what? No, let's keep it simple. There we go. B means bird, C means cat. Dog's just going to have to be A. It's just what we got to deal with. All right, so here's where this gets tricky. So just like before, right? Exclusion and inclusion. I have a bunch of things. Just like up here, I had to make sure I'm only counting things. Count things once, right? I got to count things once. So this is where we're going to use this concept of inclusion and exclusion, right? So let's start out with this here. So I need to find how many children have a cat, a dog, and a bird. Before we get into that, let's map it all out. So we're going to have an equation. So this is actually an equation question here. Can I do, hold on, can I, yes, okay, I want to do, here we go, okay. This is going to be easier if we can see the actual question here. So what we're going to do here is, so again, principle of inclusion and exclusion here. So what we have is we want to find the number of A union B union C, right? Number of dogs plus birds plus cats. To find that, to properly map that, well, I take the number of so the dogs plus the number of the birds plus the number of the cats, right? So what's happened here? Dog. Sorry. So I'm doing the dog. So these are all getting counted. Oh. So that's getting counted once. That's getting counted once. Cats counted once, counted once, counted once, counted once. Birds counted once, counted once, counted once, counted once. So perfect. I've done it, right? Well, no, because I have these ones here are being counted twice, right? And this one here is being counted 3 times. So there's an issue there. So how can I deal with that? Well, what I need to do is I need to start subtracting some stuff, right? So we're going to start out with this one here. What about this, where my mouse is? I think you guys can see my mouse. So we need to take away the number of A intersect, which okay, I'll just write it in. A intersect B. Oh. Right, which is this part here. So I've taken one of those away. Ooh, can I make that smaller? Nothing I can do? Crap. Ah. So I got to take that away. Okay, so that's why I'm doing that. So now I'm going to take away the number of A intersect C. Right? So which one of these is that one taken away? Here's A, here's C, this one. Oh. Then I'm going to take away the number of B intersect C. Is this one here? Okay. So, oh, sorry. Sorry, these also get taken out, right? So B, for example, B and C, this is a part of that here, right? That's a part of B and C. So, and that's a part of these ones here. So I've taken this away once, twice, 3 times. What's the problem? Now it's not being counted, right? So I need to add that back in. So now I need to add in the number of A union B union C. So what I have here is I now have a formula. Oh crap. Okay. Sorry, I just gotta erase some stuff here because I had to move this darn equation. Here we go. So this is intersect, intersect, intersect. Okay, so now everything's being counted once. So now we are good to go. Do you see how I use this as a reference to a visual reference to figure out if I'm doing it right? Now I'm counting everything once. Now I'm good to go. All I got to do is move those numbers in and we are good to go. So let's go and do that. Now, at some point here, this is going to turn into like an algebra equation, which is kind of where we're going with this. Because like what we know is that so first off, let's fill in some stuff we do know. I do know that two children have only a cat and a bird. So there's two there, right? A cat and a bird. Three children have a dog and a bird. And four children have only a dog and a cat. So I do know that. That's something I do know. I know these counts. I can't just put 13 here. I know that's going to be wrong. So I'm going to leave that alone for now. So let's start substituting stuff in. So first off, do I know this part? Yes, I know that there are 28 children. Equals. Now, I really recommend, you notice how I'm putting the space here? Do that. It makes it easier. So now I'm going to substitute stuff in. I know. So, because remember, I have to take away stuff. So I just put in what I know, and then this will give it. So number of people who have a dog is 13. Plus number of people who have a bird is 13. Plus number of people who have a cat is 13. So you notice how I'm leaving these spaces, right? So it's easy to figure out which one's which. Now, what about this A intersect B? This A intersect B. Well, that is this part here, right? What's the problem? The problem is I don't know this. And in fact, that's what I'm trying to find. I don't know what the heck this is. Is there something I can put in its place for now? Could put a question mark, but in math, we don't put question marks. We put, usually it's the letter X, right? So I'm going to say this is X. So what does that mean? So A intersect B. A intersect B, right? Remember, that's this stuff here. Oh, well, I just got to add these two together. So that's actually, now keep this in brackets because this is important. It's 3 plus X. Because remember, I'm not adding on 3 plus X. I'm taking that away. So I'm going to eventually need to distribute this negative. So keep it in the brackets for now. So now we're going to subtract the number of A intersect C, right? This stuff, 4 plus X, because that's what that is. It's 4 plus X is the intersection there. And again, brackets, so number of 4 plus X. Then at the same time, I'm going to take away B intersect C. That's these things, X plus 2, right? So 2 plus X. It doesn't matter if you do X plus 2 or 2 plus X. It's the same thing in this case. So I have my added stuff here. I have my subtracted stuff here. And then do I know a number for the intersection of A, B, and C? That's this part here. Yes, I've said that this is X. So right now, this looks incredibly complicated, right? So let's simplify this. So 28 is just, that's just 28, right? I can't do anything there. But I can take 13 plus 13 plus 13 and get 39. Now I'm going to distribute this negative sign, right? So negative, this is, imagine if this was, hey, what if I gave you $5 times, maybe I have 4 people plus a tip, which I don't know how much I'm tipping yet, but I'm going up to the bar 5 times to do it, right? So if I'm tipping $1 at a time, well, this one's 20. 5 times 1 would give me 5. Oh, I'm paying $25, right? So you think about it that way. So, but in this case, there is no 5 here. There's a little invisible 1 there. So negative 1 times positive 3 gives me negative 3. negative 1 times a positive x gives me negative 1x, or just x, right? Negative, sorry, in fact, let me actually show that I'm doing this here for each of these. Negative 4, negative 1 times 4 is, well, negative 4. Negative 1 times positive x gives me minus 1x. Again, though, I just write x. That little one's invisible. Now it's weird like that. Negative 1 times positive 2 gives me negative 2. Negative 1 times positive x gives me negative x. And then I'm still just have this x here, right? So let's combine like terms. You notice I'm highlighting stuff here. And we'll go blue. So 28 is equal. In this case, I'm just going to go, I'm actually going to condense it now. So 39 minus 3 is 36. 36 minus 4 is 32. 32 minus 2 is 30. So 28 equals 30. So I have negative x, so minus 1, minus 1, minus 1, plus 1. So minus 1, minus 1, minus 1, plus 1x is negative 2x, right? Negative 3, it's negative 3x plus 1x, right? So that's where I'm getting negative 2x from here. So minus 2x. Okay, now that looks like something we can actually work with, right? So that's a little bit easier. So what do I need to do? There's a couple things I need to do. One, I need to get rid of this 30. And two, I need to get rid of this negative 2x that's being times into my x. Negative 2 that's being times into my x. Okay, so let's do that. So first thing, I'm going to subtract 30 from this. Why am I subtracting 30 from both sides? Well, because these bad boys will cancel out. So 28 minus 30 gives me negative 2, which is equal to negative 2x. So right now, this is negative 2 times x, right? So I got to do the opposite. The opposite of times in by negative 2 is dividing by plus 2 or negative 2. By negative 2. So I'm going to divide both sides by negative 2. It's hard to see because I'm so zoomed out, but these are divide symbols. So what is negative 2? Negative 2. Oh, negative 2 divided by negative 2 gives me plus 1, right? So 1 is equal to, these cancel out, right? 1 is equal to x. So this is saying that, hey, 1 is equal to x. Yay, hooray, I've done it. I've answered it. Yes and no. So we just did a boatload of work, right? Reread the question. We've spent 10 minutes on this question. Reread the question. What does the question want us to do? 1, how many children have a cat, a dog, and a bird? That in that case is X. Yes. So question A, 1 child has a cat, dog, and bird. All 3. How many children have only 1 pet? So in this case, now I can start going through this. So now let's think about this. How many children have a dog? Well, it's 13 have a dog, right? 13, and I'm only going to write this once for this, right? 13 children have a dog, minus the 3 people who also have a bird, minus the 4 people who also have a cat, minus the 1 child who has all 3. It's 10, that's 6, that's 5. 5 children have only a dog. I do the same thing for bird and cat. So pause the video, do these 2. I'll have 6 children have a cat, right? Because it's 13 minus 7. And then I'll have, so 13 minus 6, I'll have 7 here. So let's quickly check this, though, to make sure, right? Because if I'm right, it should all add up to 28, because it's 28 kids, right? So 5 plus, I don't know why I'm using a calculator, plus 7, plus, so 5 plus 3 plus 7, plus 4 plus 1 plus 2. plus 6. Ding, ding, ding. Checks out. 28. Okay. So now we can do question B, which is asking, how many children have only one pet? Now you can do this in notation. Don't write this down, but you could do this that, oh, in set notation, this would be the number of A minus the number of A intersect B minus the number of A internet, and so on and so forth. In this case, you can use just basic numbers at this point. Remember, this set notation here, which I really recommend you guys actually box that. Oh, crap. Right? Oh, come on. Yeah, good junk. Right? Box that. That's important. That'll come later. That works. That's universal for 3 sets, guys. For 3 sets. So you don't have to think about it all the time. So instead of doing set notation, now in this case, I can just do basic numbers because I've done all the pre-ground work. The set notation just helps you organize yourself. So it's 5 plus 7 plus 6, right? So that would give me 12 plus 18. 18 children only have 1 pet. Okay. Okay. Oh crap. Here we go. Okay, first off, let's go to single page view. Second off, let's get rid of this page now. Nice. Right, I didn't break anything there? No, I did not. Okay, cool. Okay, we're gonna do another one here. Which one do I want to do? Winning the game. I don't really want to deal with that one. I think you guys are okay there. Correcting errors that involve sets. You guys are capable of doing this because this is just, you just have to do it correctly and then like figure out what they did wrong. You guys are good there. Let's do this one. I like this one. In this case, I'm going to be referencing what they're doing here to give you guys some ideas. Because one, this is a real world practical skill. When you use Google, this happens every single time. All right, so example 2. So Hillary and Liam are working on a project for their world issues. I'm going to put that down here. Working on a project for their world issues class. They need to use the internet to gather information about popular culture, especially a social criticism on television. Liam suggests they search for popular culture using a search engine. How can they refine their search to narrow down the number of hits? Now, for example here, let's use this one. For example here, let's say I wanted to, just social criticism. Going to be a bajillion, quintillion, thousand results, right? Remember, what am I looking for? I'm looking for social criticism on I'm looking for popular culture on social criticism on television. So I could do that. Popular culture on social criticism on television. And I can see immediately, okay, I'm getting some better results. Now you might not know this, but if I in Google, if I put quotation marks, the words popular and culture must be together then. If I use this, social criticism, now social and criticism must appear like that. It can't be something like, and social people criticize. No, that's not together. That's not together. It's only going to now give me social criticism together. And maybe now my results have decreased substantially. So here we go. 49,800 results. Whereas I go back a little bit, 146 million results. So you can do techniques to enhance your searches, and that's what they're trying to do. Now, I like this question because they do a they so this is their solution, right? So how can they refine the search? So one is by only searching with that, but I like this because they're adding some visuals to it, right? So what they did here was, no, I'm not even I'm gonna use theirs. So you can see here, if you look at the left side of the screen, too many results, right? They had about the same number of results we did, just too many. So they put popular culture in quotes. All of a sudden, what's happening here? It's only giving you the part of this set that has the words popular and culture together. Again, it's not going to give you popular people love culture. Popular and culture are not together, so we'll not give you this anymore. Okay, so they did a subset, but maybe what they're really looking for is they know their answers only in this part here. So what they do, television. So now I want to look for popular culture in television. Oh, the results have gone down substantially. I've gone from 186 million to 6.5 million to 2.5 million. So remember, they're just doing further and further um, um, more detailed search terms here. So again, but if you're mathing this out, this is what Google actually does. So you can see they keep adding search result after search result. They're setting limitations. Popular culture and television shows and social criticism, for example. And all of a sudden, I get this part here, which is really what I'm looking for, which is 962 results. All of a sudden, I have reduced the fluff, the stuff I don't care about, dramatically. So at this point, I actually think you guys are pretty good to take on everything here because it really all comes down to, can you do this? Make sure you guys write this down. And in fact, put this onto your formula sheet. So take this. Go. So take this and put this into your formula sheet here. Now, there's nothing actually here on it. So make your own little separate section here in this case. So this is the principle of inclusion and exclusion. I'm going to make this smaller just so it fits. Right? And if you want to reference, what is this? Makes sure things are counted once. Again, maybe you're a visual person. Circle, circle. Nope, just gonna have to deal with it, I guess, on this one. That's why I swapped to a different PDF browser. It's just making sure things are counted once. All right. So at that point, I'll cut you guys loose. Good luck. If you have any questions, let me know. Again, use your textbook formulas if you get stuck. But try it out. Don't rely on them immediately. You don't learn if you don't struggle, okay? So if you are struggling with this, that means you are learning. All right.